quick tour of where we are with the first simple cycler testing on the bench. There we can see the cycler printed circuit board assembled in its box, cheap case that I was mentioning. In this one I've just set it up for normal Civic and Insight packs, so we've got one 12 volt 1.6 amp supply for the fan and the electronics, and two 90 volt supplies for the IMA high voltage charging side. And also in the background here you can see we've got one of those 300 ohm 100 watt load resistors connected to the printed circuit board here. This connection here is the high voltage battery connections, and the pack is just over there connected up. We've got the typical SparkFun 16x2 serial enabled LCD, and that's connected to the LCD stroke logging output there. And this one is the 12 volt supply for the fan. Obviously this is just a normal Insight pack, so it doesn't need the PWM drive, this particular one. Now what I can say at the moment from the initial testing is that the hardware functions as I expected, which is good, but the software needs some work. The button, which I've got here at the moment mounted, you can mount a remote button. That's not changing the functions as I've programmed it to at the moment, so that needs some work. Basically what the hardware does is it monitors the voltage of the pack and calculates the current and that sort of thing from those parameters, and the power, ampere hour in and out, etc. And it controls the high voltage power supplies using a relay, little pick here, and it controls the high voltage load using a high voltage FET there. And basically it just cycles backwards and forwards, monitoring the voltage and outputting the data either on the screen or to the Excel spreadsheet. Now I'll just turn it on, see if we can get anything on the screen. And we can. And on the screen there we've got, on the top line we've got hours, minutes and seconds, so incrementing there. On the bottom line we've got the mode, the charger's in. V is the voltage. I haven't changed that to an actual voltage yet, that's the raw input from the ADC. And then we've got charge mode or discharge mode at the end there. So if I actually press one of the buttons and just turn the pack on, so I press the button, right, that's actually gone to mode 2, as you can see there. That's actually discharging now. It will discharge until the voltage falls to a preset point or a certain period of time elapses, or you press the button again. Press the button again. Now I've gone into charge mode, and now it's charging, and again it will charge now until a certain amount of time has elapsed or voltage has reached a certain point, or you press the button again. Now mode 3, now that's in the cycling mode. What it will do now is it's charging initially. It will charge now for a set period, then it will discharge, then it will charge again, then it will discharge again, and then it will finally charge again to the predetermined voltage. Now this obviously would take some time, several days, almost probably a week, but that's basically the gist of it. So a bit of work to do on the software, but that seems to be working, or the hardware certainly side of it seems to be working okay at the moment. Just one final point, just turn the pack off and the main supply off. Because I'm only using two high voltage power supplies, I've got a little jumper here just across the end, the last power supply point that just completes the circuit for the HV output side. If I had another power supply there, then obviously it would be capable of charging packs up to 260 volts, and that's what the circuitry here is capable of dealing with, up to 300 volts. So there we are at the moment with the simple cycler testing.